Welcome everyone to the session on State of Media Content Production on AWS. My name is Konstantin Wilms. I'm the Global Tech Lead for M&E at AWS, and I'm joined today by John Stanley, who is the Head of Systems at Method Studios, coming out of Melbourne, Australia. So the agenda for today is largely around the state of media content production on AWS. So you can think of this as a state of the union, what best practices are applicable to deploying content production workflows on AWS. And we'll start with an overview, the changes that we've seen during the past year in terms of content production in the cloud. I'll pass it over to John, who's going to talk about some of the challenges that they've seen with on-prem rendering, their journey into the cloud, and a number of things that they learned along the way. To wrap up, we'll talk about how to actually go from where you have deployed infrastructure, rendering, storage, etc., and enable new workflows around virtual workstations for content creation. We'll talk about some of the content production services and partners available on AWS. And really, this is about state-of-the-art and prescriptive guidance around AWS services and innovation areas in the cloud. So where can we start? Let's start at a high-level view on content production in the cloud. And this should be familiar to everyone. This timeline of development to pre-production, to production, post, and final distribution. We can map that out into various buckets here around acquisition and ingest, the notion of various creative tools, if that's for editing or conformance or delivery or mastering or even finishing. And central to that is obviously storage and compute in the cloud, as well as the ability to push that downwards to fulfillment and delivery. So there's been a consistent pace over the past few years around the render, compute, and infrastructure areas towards the right-hand side of this flow here. But we have also seen over the last year that there's been an accelerated expansion upstream of the compute and storage elements. So the areas left to this in terms of creative tools, acquisition and ingest, as well as fulfillment and delivery, we've seen a lot of expansion in terms of cloud-based workflows into these particular subdomains, if you will. And finally, we've actually seen quite a lot of similar market innovation across, if you consider supply chain and archive, data science, direct-to-consumer, and broadcast workflows. So this is important from the perspective of that these other subdomains, if you will, are parallel tracks. So any innovation that happens there, we're actually able to well repurpose into content production workflows. And as a practical example, you can think about virtual editing and say vision mixing. These actually share commonalities in infrastructure, as does, for example, conformance edit. So these span production, broadcast, and supply chain domains, which is very interesting and allows us to optimize things like editing cloud across multiple domains, take the learnings from those individual subsegments, and then create a better experience, in this case, for example, for artists. So for content production, if we look at that specifically as a native cloud capability, we've seen 5 areas that have had significant growth within AWS from a customer perspective, across various domains, be that enterprise or startup, smaller VFX studios, larger VFX studios as well. And that spans these 5 categories here. So virtual creative, obviously virtual editing and artist workstations. There's been a massive ramp up in demand for those over the last year. Collaboration, this is a interesting byproduct, if you will, of having to work remote. So we've seen a big adoption of ancillary services where, say, production management has been expanded to support remote collaboration with whiteboarding and other types of use cases. In terms of visual effects, both on the application and from a rendering point of view, more applications need to obviously be onboarded as usage increases. Either on the workstation level or on the back-end level. And this is specific to remote workers, right? We want more tools to be available so that no one has to run bespoke on-prem infrastructure And that enables us to move a lot of these workflows directly to the cloud and keep them there. In terms of infrastructure, there are a lot of new service features that we've added this last year, as well as deployment solutions to enable everything to the left of the storage and compute realms, if you will. So easier deployment of creative workstations, an easy ability to audit them. And that really brings me to the last point, which is content security. So there have been a number of initiatives this year around standards and compliance bodies, basically in order to ensure that customers, be that big or small VFX houses, can easily be onboarded with the lowest barrier to entry. So we've done a lot of work specifically around Movie Labs, Vision, the CDSA app and cloud control framework, and internal efforts, solutions, best practices, security guidelines, etc., in order to enable folks to deploy infrastructure a lot faster with a lower barrier to entry while still keeping everything secure. So bearing this in mind, one of the key requirements to enabling production in the cloud is really the ability to burst not only the compute, as we have done in the past for, say, traditional render workflows, but also the workforce. So in other words, the remote workers, the virtual workstations that they require to enable the artists to work remotely on flexible infrastructure without having to sacrifice either user experience, peripheral connectivity, or any other matter of things that they are well accustomed to working with and expect. So let's take a look at these two areas. There are two areas here that are critical, namely the location of our virtual production resources. In other words, how far are they from the artists that need them? And what does the service infrastructure look like? How do we address the complete end-to-end domain of content production in the cloud? So the first of these obviously is how do you look at global reach for your studio? And this is equally applicable for a large as well as a small studio. And one of the things that is important here is that with the global infrastructure that AWS has across all of these regions, local zones, multiple POPs, availability zones, etc., across the globe, the key thing here is that we can start to look at and implement a model that basically follows the sun. So a practical example here is that we can store assets in, let's say, a US West 2 region in the continental US. We could potentially do high fidelity online rendering or say editing in LA local zones with editors working out of, let's say, for example, Santa Monica or Burbank at low latency. And then we can do things like conformance edits on the finished assets and media and have that run 24/7 across the globe by moving the assets to where the artists are via, say, AWS S3 batch operations or other mechanisms to move the content around an object store. So that allows us to do things like, for example, do final conformance and finishing in a completely different area around the world. And this allows us to have a complete workforce that is truly distributed across the globe. So especially in the times that we find ourselves in now, this gives a great amount of flexibility in terms of remote workers, where they can work and how they can access, for example, their jobs, their edit stations, and so forth.
Thanks, Con. So today I wanted to talk about the work we've done over the last 3 years as we've moved towards extending our on-prem render farm into AWS. Method Studios is an award-winning global VFX company. We work on features for TV shows, advertising, and in Melbourne, over the last few years, we've created VFX and animation work on Game of Thrones, Jumanji, Aquaman, Terminator, Dark Fate, and a bunch of other great projects. So back in 2017, we had an especially big year when we were awarded the Disney movie Christopher Robin. Rendering Winnie the Pooh as the main character with lots of close-up shots, dealing with a fully CG bear covered in fur, it was a really big rendering challenge for us. So at the time, we'd been using ThinkBox Deadline to manage our render farm for maybe 15 years, and AWS had recently acquired ThinkBox. So it was this existing relationship that led us to work with AWS on a proof of concept for cloud-based rendering. Up front, we had a few challenges, a few problems to solve before we could get renders happening in AWS. How would we present our data to the render machines running in AWS? Where would we store that data? And we needed high performance storage capable of serving terabytes of data to thousands of render cores. So what would control the scaling up and down of this new cloud render farm? How could we seamlessly integrate EC2 instances with our existing deadline managed on-prem farm? So when it came to solving the problem of how to present textures and geometry to the EC2 instances, we considered a number of options. The first and simplest was to present our on-prem NFS server directly over our direct connect to the EC2 spot fleet in the Sydney region. This approach is problematic for a number of reasons. There's around 13 milliseconds of latency between our studio in Melbourne and our nearest AWS region, which is in Sydney. NFS simply wouldn't work efficiently over that kind of distance. We wanted to take advantage of hundreds of EC2 instances, and this would create tens of gigabits of traffic between the cloud render nodes and our on-prem NFS server. Getting that kind of throughput over a VPN is a major challenge in itself, not to mention the cost of all the egress traffic. So the solution we arrived at initially was to use EFS. EFS was appealing to us as it's an NFS service managed by AWS, so it's easy to set up, and in its default configuration, it's easy to scale back to minimal cost when you're not using it. Its default performance setting, though, wasn't suitable for our use case. It uses a burst credit system tied to the amount of data you have stored on disk. So the more data you have stored in EFS, the more aggregate performance you can get. Whilst that's great if you're storing hundreds of terabytes, in our environment, we want consistent performance regardless of how much data we have stored in the cloud. So instead, we use the provision throughput setting, which keeps performance predictable, albeit at a higher cost that doesn't automatically scale back when it's not in use. So fast forward a little, and let's have a look at where we're at today. Of course, as years go by, the technical requirements of rendering only get more demanding. So now we're working on shows where frames need to be rendered at 4.5K resolution. This is the sort of work where having access to cloud machines with lots of RAM and CPU cores really pays off. Frames that might struggle on our on-prem hardware can really take advantage of those big EC2 instances. Everything is managed using the same deadline instance that manages our on-prem farm. As EC2 workers come online, they appear dynamically in Deadline Monitor alongside our existing farm. That means there's no overhead to managing machines just because they're running in the cloud. One of the less obvious advantages we've found to bursting into AWS is the reduced impact on our on-prem storage. So I/O requirements from heavy render activity can have major impact on our artists. It's hard to stay productive when your storage can't keep up with you. So moving that heavy I/O workload to EFS protects performance for our artists. And as a result, it boosts productivity and general happiness around the studio. So this gives you an idea of where we're at today. Running alongside EFS, we've added an all-flash Cumulo cluster. We found EFS to be well suited to the larger image and geometry files, but when it comes to smaller files that make up our software, we needed something with lower latency, and that's where Cumulo comes in and gives us really fast application startup times. Having our storage located in AWS meant we had to build a system to figure out what data was required by render and then copy it up to the cloud. We also had to make sure that when a frame finishes rendering, it's back in front of the artist straight away. So let's have a look at the components of that system now and give you an idea of what's involved. So the first challenge was to be able to programmatically generate a list of dependent assets and software required to render any given shot. We already had the ability to track dependencies within our toolset, and this was one of the key things that allowed us to get up and running so quickly. Within about 2 weeks, working with only a team of 2 people, we had built the basic infrastructure and software. I still remember now how excited we were getting those first rendered frames back from the cloud. And we use a database to track any files stored in the cloud. Before transferring any data, we check against that database to see if a given asset needs to be synced. Anything not already in the database is added to the queue. That queue feeds a farm of sync workers, each working to move data to or from the cloud storage. One of the things we learned along the way is that when creating a sync system like this, you have to design for failure. An asset might fail to sync, could be a network problem or a bug in some code or any number of reasons. So we use Deadline to capture any errors resulting from missing assets. Those errors automatically send off a request to retrieve any missing files. The failed task will then wait for the data to arrive and resume itself once the files have made it onto the cloud storage. Another important thing for us was having visibility of the sync queue. When a high priority render is waiting on data, we need to know how long until that job can start. So we created a web app to show the state of the queue and any transfers that are either in progress or waiting. Going into this, it seemed logical to us that there were certain types of render more suited to the cloud. Those were CPU or RAM intensive jobs. Tasks that require terabytes of simulation data would likely be better off kept on-prem to avoid the data transfer time and costs. So as we started to dig in though, it became apparent we could now access machines with hundreds of gigs of RAM and more than 100 cores. So previously impossible RAM or CPU intensive workloads could easily be rendered on EC2. These more powerful machines also lend themselves to running lots of concurrent tasks. We run 10 or more simultaneous renders on a single machine. So that machine only takes a single license of our render software. Bursting into the cloud, we want to make sure of two things. When we need to expand our farm, we want to be able to go big quickly without any manual intervention. And then when that peak in demand goes away, we want to make sure we're not paying for resources for a second longer than we need to. So we built tools to watch Deadline for queued tasks that were suitable for cloud rendering. Once on-prem render capacity is exhausted, we can scale up our spot fleet and then within a few minutes, jobs begin rendering in the cloud. As soon as there are no more queued tasks, Deadline shuts down any idle machines, and this makes sure we're only paying for compute while it's in use. It's so easy to spend money very quickly with this kind of compute capacity. We keep a close eye on our spend using cost allocation tags. We have alerts to warn us if we're going over our forecasted budget. And then just like every other metric, we have dashboards tracking costs. So we always have visibility of our spend. Sometimes we encounter a scenario where our asset sync system has failed to copy something needed by a render. So we created a virtual workstation using an EC2 GPU instance. We set it up exactly like one of our on-prem artist workstations. So anytime we need to troubleshoot a broken render, we just connect to the cloud workstation using Teradici. From here, we can fire up a scene as if we were running it in our studio and quickly identify any problems. When a render completes on AWS, the finished frame or data is synced back on-prem so that the artist can review their work. But renders can sometimes take hours, so it's important for artists to be able to see their frames before they're complete. For maximum efficiency, we want to get feedback as fast as possible from our render farm. Wasted render time is expensive, both in terms of artist time and the cost of compute. So to address this, we created a web application that allows artists to see previews of their frames while they're still rendering. Now, I don't think there's really such a thing as too many graphs or too many dashboards. So we really take advantage of all the metrics coming out of CloudWatch. We've got Grafana dashboards tracking EC2 metrics, storage, bandwidth, cost, and just about anything else we can think of. And just because we're running all this in someone else's data center, it doesn't mean we have to lose visibility of what's going on. So 3 years later, and now cloud rendering makes up a key part of our render farm strategy. Our focus is now less on CapEx purchase or hiring equipment and much more on using the cloud to take care of those peaks in production. Initially, there were manual processes and tools to develop, but over the years, we've automated just about everything. We're now spending less time dealing with racking servers and managing firmware updates and replacing broken hardware. We've developed ways to reduce the time it takes to get a finished frame back in front of the artists. It means we can just keep raising the bar on quality and turn around finished work to our clients quicker than we ever could before. So thanks, and it's back over to you now, Con. Thank you.
So thanks, John. John touched on some key points that have driven adoption of cloud-based infrastructure for creative work over the last year. So what we'd like to pivot to here is content production state of the art. So given what we've heard so far, how do we look at this from perspective of designing a state-of-the-art solution for content production today using the latest services on AWS, as well as solutions and partner offerings? And really the most consistent request that we've seen is how to get virtual workstations running on top of AWS in the cloud as a transparent experience that enables remote work without sacrificing any part of the creative experience or security and other important aspects of these workflows. So from a high-level perspective, we can look at this from perspective of how do we plan and drive our initial Cloud Studio design using 4 factors. So location and device strategy, here we're thinking about thin clients, low latency, etc. End user experience, we're considering simple deployment and access with applications, assets, and we want this to be immediately available to the user for use. So there shouldn't be a delay, there shouldn't be a need to hydrate this and spend time waiting for assets to arrive. And that sort of gets us to application requirements. So how do we match the instance families on AWS, EC2, the network compute, how do we match that to the persona of the end user? And finally, we need to build all of this. So what do we look at in perspective of tooling, infrastructure, and security? So like I said earlier, we don't really want to have to sacrifice the front-end tools that the artists use by creating brittle infrastructure and tooling, as well as insecure workflows. So this is a good slide that demonstrates walking through how to build virtual workstations as a first step to building a complete studio in the cloud. So we can start with a known challenge, namely that obviously no 2 workstation flows are the same. Most content flows or workflows or pipelines are different, even for the same production. So how do we scope a workstation to meet all these varying specs? So what I'll start is, you can see there are a number of categories, if you will, on the left-hand side, and I'll actually walk through and hit those by discussing how we can own, operate, and build artist workstations in the cloud using the flow on the right-hand side. So let's step through the thought process here, and we'll start with the artist and we'll work backwards to their ideal compute requirements and environment, if you will. And along the way, we'll map those to the different personas, media and access requirements, etc. So starting with the artist, we can consider what display resolutions, what is the quality, the bandwidth, and really this relates to creating a persona for different artists and creatives. And we found this has been very successful in the past, and we generally recommend that if you're building a virtual workstation on AWS, if you're considering, for example, G4 instances as, say, the underlying EC2 core of your fleet for your artists, that you look at creating personas. And the personas will map things like the workflows, the display resolutions, network and storage, pixel streaming protocols. Do you want to do this via native or web clients? And what kind of client-side peripherals are required? So there are a number of options here. If it's related to pixel streaming, there's the choice of Teradata PC over IP. We also have nice TCV as a native AWS offering. You might want to use remote desktop for some kind of QC or conformance or technical operations use cases. And you may want to do this over web or native. So the thing here is to be able to spec a workstation, make sure that it can run all of the tools that you need, and then make sure it meets all the requirements for the artist. Like I said, what kind of peripherals are required, what kind of latency is required, and really what is the workflow behind that. And here you can see some of the applications that customers are running on top of their artist workstations in the cloud. So if we look at this, the next step from actually building and scoping and architecting for the virtual workstation is how do we handle flexible storage? So to bring the assets, to bring the media, etc., to the artist workstations, we're going to need flexible storage that is deployed on AWS. And the important thing here is we might want to run that in region, we might want to run that in local zones, and maybe in some cases we have a hybrid model where we'd want to use a partner that can deploy their infrastructure on premises as well as in the cloud. So I've selected 3 options here that are fairly popular and cover a wide variety of use cases. We have Amazon FSx, which is fully managed, exposes SMB and NFS, and then it has backing obviously to object store. And it's the same for the partner offerings like Cumulo and Weka, which provide scale-out file systems that are high performance and expose various ways to attach their file system endpoints to local workstations running on Linux or Windows. So the important thing here is to select based on the profile or the persona and the operating system on the client. So the options that are shown here are able to tackle this notion of, can we expose SMB or CIFS? Do we also have support for NFS from the same underlying file system? And are we able to utilize object store or S3 as a data lake to avoid having to build custom infrastructure to move content back and forth? And this sort of brings us to the next point, right? We've talked about building virtual workstations. We've talked about storage for the workstations. How do we actually bring those closer to the artist? So there are 3 factors here. One is performance, another is consistency, and a third is capacity. So in other words, for performance, we want to make sure that the latency is low enough that any artistic application actually performs well, right? There's no jitter, there's consistency in the frame rate, and that brings us to consistency, right? And that's largely around frames per second. We want to have an experience that's not swimming frames. For example, an artist working on a 3D model, rotating the model, we don't want to see any jitter in that. And then finally, capacity. This relates to bandwidth. So how do we optimize the pixel streaming display protocol to give good fidelity for the edit, but also not consume too much bandwidth to make it just infeasible to deploy for home-based remote editors. So one way to do that is through AWS local zones. So earlier this year, we added the ability to easily enable local zones from the EC2 console and also SDK and APIs. And this allows extension of your compute infrastructure in a region to the direct geographic proximity of your users. So this is super useful in use cases where we need super low latency compute, we need consistent performance for artist experiences, and we need to be able to do this in a fashion that also enables partner and AWS services that are critical to these workflows to be used. So the idea here is that you're able to extend your workflows to the edge, but not lose any of the overarching in-region services that may not be available in local zones, or any of the partner solutions that are actually used to move, own and operate your media in the cloud in region. So to wrap up, let's take a look at the current state of the art across AWS services and innovation areas. This is a list of the most important service and innovation areas this year, specific to content production. So on AWS ThinkBox deadline side, we released the Render Farm deployment kit, which is built on top of the Cloud Development Kit. And this enables you to, in an automated fashion, deploy, configure, and manage your Render Farm infrastructure in the cloud. There are also a number of other features that were released for deadlines, such as SQS notifications and high availability for the management plane. And this enables you to do things like create extremely granular cost controls for running your render workloads in the cloud. We also released the Network Firewall, the AWS Network Firewall, which is a fully managed firewall that runs inside of your VPC. And specific to render and production workloads, this allows you to have extremely granular, once again, access control and control policies. And this is useful for production workloads that need to meet a high level of regulatory or standards-based body compliance. On the pixel streaming side, for nice DCV, we released a number of features here. So the ability to manage sessions across your fleet. There are also optimizations on the protocol side. So Quick is an optimization there. And this allows us to do things now and work forwards towards, actually one of these was released this year, 60 FPS support. But it also enables us to work forwards towards things like very low latency and advanced USB support. So Wacom pressure sensitivity, etc. Digital audio workstations that require remote VSTs. There's quite a host of use cases that will be enabled through advanced protocol enhancements to the NICE DCV stack. Local zones we talked about, the LA1 and now LA2 local zone. So these are both in LA. The ThinkBox Marketplace, we recently released RenderMan for AWS. So that comes in 3 flavors. One is standalone. The second has affinity to Maya. And the third iteration of that has the ability to work with Houdini. So it tackles all these 3 use cases. You can see a lot of the other user-based licensing options for rendering listed at the bottom of this page. But that's been highly requested and is now available for use. At least on the EC2 front, there are a number of really non-content production specific use cases, such as hibernation for T3 and T3A instances. And really these kinds of things enable running of bespoke, if you could think of a use case here, licensed servers that you might want to hibernate while the workloads are not running. So it really enables us to enable or to be able to deploy some of these licensing and specific applications that had trouble operating in the cloud over the previous years. And then lastly, on the cloud innovation side, there's been a lot of work around virtual production. So we've seen an intersection of game engines, spatial and M&E domains to drive a wide variety of use cases here. And this has covered everything we've seen from virtual compositing to pixel streaming for VR to even look visualization for set and on-set production. We've seen a lot of innovation in TVIPs and RAW sectors, if you want. So the ability to stream directly from S3, have accurate color grading, and have perceptually lossless previewing and QCing of master level assets. And a lot of this has been done by the partners that we have in the M&E space. So finally, to wrap up, if you would like to learn more about content creation on AWS, there are a number of resources here that are available. And these encompass development, tutorials, webcasts. There's a content hub that we have for Studio in the Cloud for content production that also contains a number of resources. And a number of blog posts that are related to this as well. So with that, I'd like to say thank you from John and myself, and please complete the session survey.